Good evening. Today we are going to discuss the assignment 6, which is optimization. And in this optimization, we are going to discuss stochastic gradient descent solution. So first of all, we are going to this in this topic we are going to we're going to learn about how to implement a gradient descent. Now, stochastic gradient descent is a optimization algorithm, which is very efficient optimization algorithm. So this optimization algorithm will like updates the model parameters using the gradient of the cost function, so that we'll be getting the model parameters which are costing very less. That means the error is very low. So first of all, we let's start our assignment. As usual, we'll be initializing all the packages, importing all the packages, random, and for the random we are going to give seed 42, numpy for the mean calculation, for the mean squared error, and matplotlib for plotting the loss data, and plotting the data that we are going to generate using random package, and sklearn model selection. In this we are going to use train test with this inbuilt function. So in this assignment, we are going to generate the data which is weight and height. So where weight is the x parameter and y heights are the y parameters. So what is the weight for? We are going to generate the weight from 50 to 120 kg. Sorted data. 50 we are going to generate 50 random weights using random initialization function, and then we are going to generate the height values, assigning height values, random height values for the corresponding weights. And we are going to, for every each and every item for x, we are going to generate the random heights, and then we need to plot the data that we have randomly initiated or generated. So this data that is random, so everyone doesn't get the same data. So we are going to plot the data line x y, and here we are going to plot with the positive, we are going to plus symbol the data for every weight. What is the height that we x and y, and we are going to plot the data. This is our data that we have generated, and then now we are going to split it into training data and testing data. So test size is 10%, that is 0.1, and then we are going to test and train, we are going to divide, and that is train size would be 90%. And then now we are in this is a linear model, so we are making a linear model. So if in the linear model we have y is equals to mx plus c, that is y is a variable and x is a variable, but where m and c are the parameters. So we are going to find the parameters, the best fit parameters m and c, using a stochastic gradient descent. Like this, that is optimization, an optimization solution. Like we are going to uh, optimize our machine learning model such that we are going to find the best fit m and c, so that we are getting a, very less error. So in here we are going to find out the mean square error. In loss function is mean squared error, which is the effective loss function we are going to use for every linear model. So y is a dependent variable weight, a dependent variable, and x is the independent variable. So since we are going to find the mean square error, and then next we are going to, n is the number of sample and y is the ith sample. Here this is the mean squared error example. So in this we have x is 1. So here we are going to implement as a code, mean square error as a code. That is a mathematical formula, and we are going to first we are going to find error. Error is the predictions minus targets. What is the prediction that we got minus the targets that we're supposed to do, and we are going to give predictions and target as the parameters, and then squared error is equals to error square, and mean square error we are going to mean the squared error, that is mean of the squared error numpy dot mean of squared error, and we are going to return the mean squared error of the particular prediction and target. And then now now we are going to update the weight and bias. Okay, update the weight and bias. So here we are going to in this gradient descent, so first of like to update the parameters m and bias, parameters m and bias c. Bias is nothing but how far it is from the like x and y axis. M is the slope. So in this iteration of stochastic gradient descent, we need to calculate the gradients of mean squared error. So we are going to calculate the mean squared error with gradient of mean squared error with respect of m and with respect of n. So that we are going these are used to create new m and c. In the gradient descent, stochastic gradient descent, we are going to find the new the updated rule for the weight and bias. So we are going to each and every time, each and every iteration, we are going to update the m and c, that is weight and bias, so that we'll be getting like a shape or the new values, such that we are going to get least errored values and good fit of m and c. So for that, m is equals to m minus of learning rate into the gradient of mean square error with respect to m, and for the bias it is the same. So next we are going to same thing we are going to implement here, that is so we are going to initialize indices, like indices select a random batch of data. All data points have uniform probability of getting sampled. So in this stochastic gradient descent, so there is a gradient descent solution and a stochastic gradient descent. In the stochastic gradient descent, we are going to use the stochastics, that is the probability will come into picture. So where we are going to, in this we are going to select a particular sample data, and in that we are assuming we are implementing to this particular sample data, and we are assuming it is applicable for entire data. So in this we are going to randomly select a size, randomly select the data. So we are going to randomly select the data, and we are going to batch that batch the data. So after that we are going to predict the y value y prediction, and then we are going to find the error. So error is prediction minus the actual target, so that is y prediction minus y match. So next we need to calculate the gradient of the loss. So gradient of m is we have the formula 2 by n of mean of 2 by batch size into x batch dot t dot of error. So like derivative, we are going to find derivative of particular what we say, uh, it is the derivative of mean squared error, and c also we are going to find it in the same way. And then we are going to update the we are going to write the update formula for the updates of weights and bias. So new c and new m, we are m minus of learning rate into gradient of m minus learning c minus learning rate of gradient of c. So we'll be getting new c and new m values. Next we are going to randomly initialize the model. So we are just initializing the model, and we are just finding the m and c values for that. So we are storing them in a dictionary where m and c values, like we are initializing with random m and random c. We are going to plot the model. So this is the data and this is the model. So you can see this is the for this m value and c value, this is the particular model that we have generated, linear model, which is you in the visualization it is we can see that is not a perfect model, that is not the perfect model. So then we are going to initialize the hyperparameters, that is learning rate that we are using, and then batch size. What is the batch size that we are dividing each batch, the sample, like x batch and y batch, and then we are going to initialize the number of iterations that it is to done. So these hyperparameters that depends upon the particular person, or in everyone can like change those things, like we can give any learning rate, or we can give, so that's a trial and error basis. So now we are going to give the like m and c, that is model of m, model of c is the model of c, and then we are going to find the losses function for I in the range of number of iteration. We are going to find the stochastic gradient descent. So for every mm, we have take, and this is the stochastic gradient descent is the function. So in this function we are going to find the stochastic gradient descent, like we are going to find a new m and c. For every m and c we are going to find the loss, and so that loss will be appended to the losses list. So we are having the losses list, so each and for every each and iteration we are getting the loss. So you can see we got in the iteration 5 we got the minimum loss, that is 2.29. So and also in 10th we got the minimum loss. So you can see you can see that uh, we can also plot the same losses. We got the losses data as a list, so we can plot the losses data like number it like on the iterations we can take the data. So that is for a particular loss we will be using m and c. What is the value of m and c for the minimum loss? So we will be, so in this observation we can find that the good model can be made for the minimum loss, that is for the m value 0.45 and c value 1.5, it is giving the minimum loss. So we are taking that values as m and c, these good values as m and c, and then next we are going to plot the data line for that. So this particular data line is being drawn, and this is the good using the stochastic gradient descent we have optimized our machine learning model, and we have generated a perfect model, perfect linear model. So this line represent the uh, it is a linear model. This is the end of the assignment. Thank you.